Welcome to your Algebra 2 10.3 video. Today we're going to define and use probability. Probability is simply the likelihood of an event, and so it's going to be a number between 0 and 1, where 0 represents 0% chance that it happens, so it's impossible, up to 1, which represents 100% chance something happened, and so it's certain. And so there are all kinds of cases where the probability of an event is between 0 and 1. The chance of rolling a 3 is a 1 in 6 chance. That would probably be considered unlikely. Tossing a fair coin and getting heads or tails, there's an even chance. In this case here, we've got 4 green balls and 1 red ball. The probability of drawing a green ball would be 4 out of 5, and so that's likely and then up to certain. All right, so theoretical probability of an event, if all the outcomes are equally likely, the theoretical probability of some event A is the number of outcomes in A divided by the total number of outcomes. So favorable outcomes to total outcomes. In order to determine how many outcomes you have, you need to consider the sample space, which is the set of all possible outcomes. So the sample space for a standard fair die is the set 1, 2, 3, 4, 5, 6. Because when you roll a die, you're going to land on 1, 2, 3, 4, 5, or 6. Okay, so we want to find the probability of using a standard 6-sided die, rolling a 5, and then we're going to talk about rolling an even number. So the probability for rolling a 5 are going to be the number of ways to roll a 5 to the number of ways to roll the die, number of possible outcomes. And so there's one way to roll a 5. It lands on 5. And there are 6 possible outcomes, so the probability of rolling a 5 is 1/6. Now, for rolling an even, this one's a little more interesting because there's more than one way to roll an even number. So when we consider our sample space of 1, 2, 3, 4, 5, 6, 2, 4, and 6 are all ways to roll an even. So there's 3 ways to roll an even out of 6 ways, 6 total outcomes. And so 3 out of 6 will reduce down to a half. Let's consider an example from entertainment. A community center hosts a talent contest for local musicians. On a given evening, 7 musicians are scheduled to perform. The order in which the musicians perform is randomly selected during the show. What is the probability that the musicians perform in alphabetical order by their last names, assuming that no 2 musicians have the same last name? Okay, so there are 7 factorial different permutations of the 7 musicians, ways to order the 7 musicians. Of these, only 1 is in alphabetical order by last name, so the probability is 1 out of 7 factorial. And so that's 1 in 5,040, so it's not very likely at all. In fact, if we divide it out, it is equal to 0.000198. Okay, so now go ahead and do the guided practice that's provided for you for examples 1 and 2, and we will go over that in class next time. So go ahead and pause the video and work out these problems. Welcome back. Now we're going to talk about odds. Many times people think odds and probability are synonymous. They're not. They're related, but they're not synonymous. So when all outcomes are equally likely, the odds in favor of an event and the odds against an event are defined as follows. So odds in favor of an event A is the ratio of the number of outcomes in A and the number of outcomes not in A. Okay, so we don't have a denominator or the total number of outcomes anymore. The denominator is the total number of outcomes that are not in A. Okay, I got the odds against A. It's the number of outcomes not in A over the number of outcomes in A. So it's the reciprocal of the odds in favor. You can write odds in the form of A over B or in the form A to B. And really, even when it's A over B, we say A to B. So the odds are 1 to 5. Okay. All right, so a card is drawn from a standard deck of 52 cards. We're going to find the odds in favor of drawing a 10, and then we're going to find the odds against drawing a club. So the odds in favor of drawing a 10 are the number of 10s over the number of non-10s. Now, if we were doing probability, it would be number of 10s over total number of cards. But we're not doing probability, we're doing odds. So there are 4 10s, okay, one of each suit out of 48 non-10s. And the way we get the 48 is there's 52 cards. We subtract off the 4 that are 10s to get 48 that aren't 10s. And that will reduce down to 1 to 12, or you can write it horizontally, and it's still read 1 to 12. Odds against drawing a club. So this time we're going to have the number of non-clubs on top as a ratio to the number of clubs. Okay, clubs are one of our suits, and in each suit there's 13 cards. The number of non-clubs are the total number of diamonds, spades, and hearts, which are 13 plus 13 plus 13, which is 39. Or you can get 39 from doing, okay, there's 52 cards, 13 of them are clubs, 52 minus 13 is 39. And so that's another way to get your numerator. That reduces down to 3 over 1, and so 3 to 1 written vertically or 3 to 1 written horizontally. Experimental probability is what actually occurs when you perform an experiment. When an experiment is performed that consists of a certain number of trials, the experimental probability of an event A is given by the number of trials where A occurs divided by the total number of trials. So the bar graph shows how old adults in a survey would choose to be if they could choose any age. Find the experimental probability that a randomly selected adult would prefer to be at least 40 years old. So we're going to use the information found in this bar graph. So if you look here we've got the desired age. So there's 463 people who want to be under 20. There's 300 people that want to be between 50 and 59. And then these, so that means that on the vertical here we are measuring the number of adults who responded with those different values. Okay, so at least 40 years old. So here's 40 to 49, 50 to 59, 60 to 69. Those are all going to be part of our sample space, or not even just part of our sample space, our event that we're interested in. We will need the total number of people surveyed, and so you can just get that by adding up all the group totals, which is what we are doing right there to get that there were 3,516 people surveyed. And so of those surveyed, the ones in the last 3 groups, the 40 to 49, 50 to 59, and 60, let's look back, 60 to 69, we want to add those 3 together. And we get that there's 1,089. We prefer to be at least 40. And so the probability that one of the randomly selected adult wants to be at least 40 years old from that survey is 1,089 over 3,516, which is about 0.310. Now, it's great if you go ahead and divide it out and give me a decimal approximation, but I do always want to see the original fraction based on the bar graph. Okay, anytime you're using a graphical display of data and you're giving me a probability, always give me the original numerator over the original denominator. So again, this is the number of people who said they wanted to be at least 40. Okay, we have our 551 who wanted to be in their 40s, the 300 that wanted to be in their 50s, and the 238 that wanted to be in their 60s. We added those together, and then we're dividing by the total number of people who were surveyed. Okay, so now you've got some guided practice to do, so go ahead and pause the video and do your guided practice. Oh, great. Welcome back. We will go over the guided practice next time in class. Let's look at some geometric probability, and these are probabilities by calculating a ratio of 2 lengths, areas, or volumes. So here we've got a dart problem. You throw a dart at the square board shown. Your dart is equally likely to hit any point inside the board. Are you more likely to get 10 points, so this area here inside the inner circle, or 0 points, the area that's left over outside the larger circle but still in the square. Okay, so our probability of getting 10 points is going to be the area inside the smallest circle versus the area of the entire board. So the area inside the smallest circle is going to be pi r squared for that circle. So that's going to be pi times 3 squared. And then the area for the entire board, it's a square with a side measurement of 18 inches. So that's going to be 18 squared. Okay. So we have 9 pi over 324, which reduces to pi over 36, which is approximately 0.0873. So you've got about an 8.7% chance of getting 10 points. So let's consider 0 points. So for 0 points, it's the area outside the largest circle divided by the area of the entire board. Well, we've already figured the area of the entire board is 18 squared. The area outside the largest circle is going to be the area of the whole square minus the area of the largest circle. Okay, the largest circle has a radius of 3 plus 3 plus 3, so 9. So we'll have 18 squared minus 9 squared times pi, all over 18 squared. So we get 324 minus 81 pi over 324. That happens to reduce to 4 minus pi over 4. We're going to put it in our calculator anyway, so you really could have done that here. And that comes out to be about 0.215. All right, so our goal was to figure out what's more likely. Because 0.215 is greater than 0.0873, you are more likely to get 0 points than 10 points. Okay, so now you need to do your guided practice for that last example, and you are done. And we will go over all the guided practice in class next time. If you have questions, please come in and get some extra help. More than happy to answer questions for you. Thank you. Have a good day. I'll see you soon.